If computers were invented by mathematicians and the first applications of artificial intelligence were actually automated theorem proving, it's kind of odd that computers are used less in mathematics teaching than any other field. Conrad, sort of, as we all know, brought this up. He argued that current mathematics instruction focuses on technical difficulties, and because these can be largely automated, or technical calculations, but largely automated using computer algebra systems like Mathematica and Maple, he argued that the emphasis should be shifted to using mathematics to solve problems which can be formulated mathematically. And I'm not the first person to say it today. Essentially, he's arguing that a shift in the teaching philosophy from pure to applied mathematics. And that is really what it's all about. And it's also one of the reasons why there's so much sound and fury about it all. Anyway, here's my first epiphany, which is my experience of using computer algebra systems in teaching. I've been doing this for about 15 years now. Back then, I was teaching a course in dynamical systems, differential equations, chaos, that kind of stuff. And I was doing it traditionally, and I used Mathematica to check the solution to my written exam problems. And that course worked well. I sent that off to the external examiner, and he was happy with that. In the next year, I discovered made a different set of problems, and found that by a little bit of customization, I could actually get the notebook from the year before to solve the new set of problems. Well, that got me thinking, if you can build a piece of software that can pass a written exam, what are we doing? Right? Anyway, the next epiphany was when I was acquainted with competence-based curriculum design. And this has been mostly built up by the medical educators. And to design a curriculum, such as freshman mathematics, one should answer the following three questions in order. Question one is, what competences do we want the students to get out of this? Or, put it crudely, why are they doing it? The second question is, how do we evaluate that they have acquired these competences? And the third question is, what do we teach? Well, people who teach mathematics will recognise that in the traditional curriculum, we answer the questions in the reverse order. And I should say I'm mainly interested these days in first year or freshman mathematics for engineers and scientists mainly. We have, at the University of New South Wales, where I do a bit of teaching on this, we've got over 2,000 students a year doing first year maths. And anyway, what the traditional curriculum does is it first of all decides on a textbook or a compendium, and then it decides on some mode of assessment, which is usually a written exam, possibly with tests. And then I remember it was in vogue a few years back to talk about competences in our teaching. That seems to have fallen out of favour again. And of course, when you've designed the course this way, you're floundering around trying to come up with some non-trivial discussion of the competences. But if we take the design methodology, then the competences are the ability to pass a written exam under time pressure without any of the aids we would normally have available. Well, the new curriculum, we're not as free as we think. A lot of engineering degrees are accredited by the various engineering associations, and mathematics is part of that, and the curriculum is defined in terms of the current technical content. I would say that that content is probably pretty much universal now. So we would want the students to be exposed to all the traditional technical content. But other skills are the ability to formulate quantitative problems using mathematics, the ability to solve them using the technical knowledge, and the ability to evaluate the solution in the light of applications. That was what Conrad was saying earlier. Anyway, these, I call these competences, they're either mathematical knowledge or mathematical meta-knowledge, which is knowledge about mathematics. Traditional written examinations. So students learn about a number of mathematical objects, such as the numbers, functions, equations, vectors, matrices, determinants, differential equations, probability, and so on, as well as operations on these objects. They learn to internalize this knowledge by repetition in tutorials, and the success of this process being assessed in written tests of various kinds. So how might we do competence-based assessment on these things? Well, in the courses I've built, students build a selection of annotated tools which they store in their toolbox. And they do this in the process of solving, I'd say, moderately large-scale projects. Is it nearly time? Yeah, right. Okay. So we're not going to finish this story, but I just want to tell you a little bit about something I discovered, which is what are problem-solving skills. And this, I heard a talk by a Professor John Sweller, who's an educational psychologist. He's written a provocative article in which he compares mathematical problem-solving skills to the knowledge of chess grandmasters. And what some Dutch psychologists took chess players, weekend chess players and grandmasters, and tried out their skills in terms of breadth searching, depth searching, and found no difference. The aspect that they found a significant difference was they showed the subjects a board position from a real chess game, and the grandmasters were, and then they had to reproduce it. And the grandmasters were clearly better at this. So it seems that you develop problem-solving skills by looking at lots of examples. So anyway, finish my assessment thing. The students did 3 large projects through the semester, delivered a report written in Mathematica for each of these, and then delivered a toolbox, and we did an oral exam on the toolbox. The pass rate hardly changed from the time when it was a traditional course to when we did it this way. The only difference was, it was about 2/3. In the new way of doing it, the less able students just dropped out. And the students that followed the whole course, did all the projects, all passed. So anyway, if you want to learn more, as I said, I've put up a video about this on YouTube. Okay. Great.